we now discuss the solution of a problem from the section Mathematical Reasoning. And the problem is related to the concept of tautology. This problem has appeared in the joint entrance examination main held on 29th June 2022 in the first shift. The given question is, let delta belongs to the set of connectives. The first connective is and, or, the implication, equivalence, that is and, or, implies and implied by be such that P and Q in brackets delta P or Q in brackets implies Q is a tautology, then delta is equal to, we are given four options, option A and option B, or option C implies, option D implies and implied by. Here delta belongs to the set of the four connectives. The first connective is and, or, implies and implied by be such that P and Q delta in brackets P or Q implies Q. This compound statement is a tautology. Then we have to find for what connective that this delta takes such that this expression, this compound statement is a tautology. We now discuss the solution of the problem in detail. P or Q implies, that is the second bracket. First of all, let us write an equivalent statement to this. We recall this result. P implies Q is equivalent to negation of P or Q. Apply this here. P or Q implies Q will be negation of P or Q is equivalent to negation of P or Q or Q. Now, for negation of P or Q, we apply De Morgan's law. What is De Morgan's law? Negation of P or Q is equivalent to negation of P and negation of Q. We write down here is equivalent to negation of P and negation of Q in brackets or Q. Now we apply distributive law. So what is the distributive law? Is equivalent to negation of P or Q in brackets and negation of Q or Q. That is negation of P or Q and negation of Q or Q. Look at negation of Q or Q. For whatever the truth values of Q, negation of Q or Q is a tautology. That means it will be always true. Negation of Q or Q is equivalent to T. So write down in that place T. So is equivalent to negation of P or Q and T. Now P and T is equivalent to P. So this is equivalent to negation of P or Q. So that is the equivalent statement for this. So we go here for the second bracket, we write down negation of P or Q. So therefore P and Q delta P or Q implies Q is equivalent to the next second bracket. We replace it by negation of P or Q, which is an equivalent statement. So that is equivalent to P and Q delta negation of P or Q. For what delta coming from this set, this is a tautology. Right. We simplify further. So let capital P is P and Q. So this capital P is P and Q. And this second statement, negation of P or Q is capital Q. Capital Q. So the above statement becomes, now to find delta such that capital P delta capital Q is a tautology where delta belongs to the set of the connectives and or implies and implied by. So for what delta P capital P delta Q is a tautology. So thus we get 4 statements to study. The first statement is P and Q, delta is and. If delta is R, P or Q. If delta is implies, P implies Q. If delta is if and only if, P if and only if Q. And we write down the truth tables for this and find out which one of them is a tautology. So in the next slide, we put the truth tables. So the truth table, and these are the options ready made for you. And P, small p, Q, small q, capital P, P and Q, capital Q, negation of P or Q. Now the 4 statements we are writing now, P and Q, P or Q, capital P implies capital Q, capital P implies and implied by Q. Now first of all, let us write down the truth values for PQ. This will be TT, TT, TF, FT, FF. These are the truth values. Now for first of all capital P, we will fill it out. T and T is T. T and F, F. F and T, F. F and F, F. So this is the T, F, F, F. Now let's come down. Negation of P. The negation of T is F. F or T. F or T is T. Negation of T. F or F. F. Negation of F. T or T. T. Negation of F. T or F is T. Right. Now forget about small p, small q. Now concentrate on capital P and capital Q. Now P, T and T, T. T or T, T. T implies T, T. T implies and implied by T. So that is what we have filled up. So all are T's, therefore it's okay. Now capital P, F and F. F and F is F. F or F is F. So it is F and F. We stop here. And P and Q is not a tautology. If it is a tautology, you must get the truth values, all of them to be true, T only. But we got a F. Therefore, it's not a tautology. Similarly, this is not a tautology. So P and Q, P, capital P or Q are not tautologies. Therefore, delta is not N and capital delta is not R. Therefore, options A and B are eliminated. Agreed. Now fill up P implies Q, P implies and implied by Q. Now F implies F, T. F implies and implied by F, T. No problem. Both are T's have come. Now next. F implies T, T. F implies T, implies and implied by T is F. Now, if and only if this one, this connective if and only if is not a tautology. Why? If it is a tautology, you must get all true. T, 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 T. But we got an F. Therefore, it is not a tautology. P implies and implied by Q is not a tautology. Thus, delta is not equal to if and only if. Thus, the option D is eliminated. So, there is only one option left, that is option C. Obviously, that is going to be a tautology. But anyway, let us see. F implies T. F implies T is T. Is T. So, all have come out to be the truth values are T, 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 T. Therefore, P implies Q will give you a tautology. Thus, delta is equal to implies is a tautology. So, the answer is option C. Therefore, the answer to this question is option C. That is the detailed discussion of the solution of the problem from the section mathematical reasoning, and the problem is related to the concept of tautology. I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.